Good evening, sir. Sir, you're muted, sir. Muted, sir.
Can you hear me?
Yes, sir. It's clear, sir.
So tell the participants that I would like to beg their forgiveness because I'll take a coffee simultaneously because I need it. No.
Okay, sir. Sure, sir.
Hope they don't mind me taking coffee while talking to them.
Yes, sir. Yes, sir. You can do that, sir. That is fine, sir.
Well, I need because I just took some medicines and all.
Definitely, sir. Definitely, sir. So participants, Joydeep sir is here. He's from Economic Sciences Department, IIT-Kanpur, and he will be addressing all your queries related to calculus of one real variable course. So please unmute yourself and ask your doubts. You can also turn on your camera if you wish to. So please go ahead. Thank you all.
Anyone with any queries?
Sir, last week we floated a Google form. Through that Google form, we received 2 queries, sir. Can I post those queries in the chat box of Zoom, sir?
Yes.
Yes, sir. Just a second, sir. I will just post it, sir. Yes, sir. I posted those 2 queries in the chat box, sir, from Dr. Kapil Jain and one Mr. Puneet.
So this first question requires a little time to work out. Okay. Hello.
Fine, sir.
It'll require a little time to work out.
All right, sir. You can skip that question, sir. Later on, we can.
It needs to work out through pen and paper, and it needs certain time. It's not just a very simple question.
Sure, sir.
I can work this out and then send it to you. You can put it across on the web. So
sure,
I
sir.
send this question right down to me by email. I will work it out and send it.
Sure, sir. So once I receive it from you, I will post it in the announcement section of our course, sir. Thank you, sir.
Question papers will be based on assignments. No, you don't test you theory. You don't have to write essay type answer or anything. They're all questions. Whether they are of filling the blanks, true and false, make a multiple choice. So that kind of question. All short answers. You just have to tell the right answer. But that would need computation.
Participant Abdul Pandey, can you just ask the question?
Hello.
Abdul Pandey, your voice is not clear. A lot of noise is coming. Can you just reconnect it? Dr. Kapil Jain, please go ahead. Unmute yourself and ask query.
Good afternoon, sir. I'm audible.
Yes, Dr. Kapil Jain, you are clear. You are
Okay,
audible.
sir. Sir, I have a doubt in assignment 5, whose result is recently out.
Okay, just a second.
Okay.
Sir, yeah, sir is there, but it's not visible. Just wait for a minute. Once sir
Okay,
joins, you
okay,
can ask the query.
Okay.
Yeah. Thank you, doctor.
Sir, may I ask?
Sir, you're muted, sir. Joydeep, sir, you're muted.
So,
Yeah.
Kapil, you have asked me that question about Riemann integration. So basically, we have to, in that particular question, we have to figure out the upper Riemann sum and lower Riemann sum.
Yes, sir.
Yeah.
Yes, sir. I have another doubt, sir. In assignment 5, whose result is recently out. In question number 1, may I ask my doubt?
Yeah. Which?
Sir, the question is that let f and g be two Riemann integrable functions on a b such that f of a equal to f of b, then integral a to b g dash f of x f dash dx. My doubt
Is these are question in the exams?
Yes, in assignment 5. Sir.
Oh, assignment. Okay.
Yes.
So what was the question again? Can you write down the question and send it across? Whether you just tell me, I might not be able to.
Excuse me, sir. I will share the assignment page with you, sir, so that it will be easier for you to.
Yeah.
Yes.
Just a second, sir.
Thanks only. I have the solution, but
Yes, sir.
This is the question, sir. Question number 1, he is asking some doubts, sir.
Yes. Let f and g be two Riemann integrable functions on a b such that f of a equal to f of b, then integral a to b g dash f of x f dash dx. My question in the part g dash fx, sir, it might be possible that range of the function f is not a subset of ab. Then how can we define g dash f of x?
G dash? No, that's I assume.
It might be possible a range of f is not a subset of ab. Then how can we define g dash f of x? I think answer could be undetermined because the term g dash f of x might not be possible to define.
Range into Riemann integrable functions in AB. So G is on R. So first they have to mention the word that G has to be differentiable. And of course you have to mention that
Range of f is a subset
G is such a function whose which can be defined on the range of f, right?
Yes.
So
it should be mentioned in the statement. So I put the answer undetermined.
Okay. Now suppose that is done, then what is the answer?
If then answer will be 0. If range of G is a subset of AB, then definitely answer will be 0. But it is not mentioned in the statement, so I think answer must be undetermined.
No, I think when you have these type of questions, there are two ways. Either you can take very strong kind of approach what you are taking, when obviously the problem is not correctly set. But another way of looking at it is that when your problem has this sort of form, when you are evaluating integral, you assume that all these things are actually valid. Otherwise, you can't write that integral. So there's certain tacit way of writing mathematical things. Like they should have spoken about differentiability of G and the fact that the domain of G is contained, I mean, the range of F is contained in the domain of G. G dash, basically. So that is more important. So that is now G dash also is a function from R to R. Okay. Because if F is a function, G is a function from R to R, then G dash is also a function from R to R. You agree that? Agree to that?
But in this statement, G is a
No,
function defined on AB.
So then what exactly? So which means now when you compute G dash, you're computing only between A and B basically. You're assuming differentiability, though you should really assume it over only on the open interval. That doesn't matter much. So okay. So G dash, then you have to write that F is a function from say AB to AB. Then you can write G dash Fx.
Yes,
So
sir.
assume
Yes.
that all those things are true, that range comes within that AB, and then you can write G dash X. So if you take that, I would think that you should take it in that spirit rather than becoming so hard on this question. So let me see what is the solution. So let me see, Murli, what is the solution? Just how they have solved it. Let me see.
Yes, sir. I'm just making it as a full screen, sir.
Okay, that's it. That's correct. I think this is okay because, sometimes you do not mention certain things like that. Okay, G. So when I am writing G dash, I'm expecting, of course, G dash is, I can differentiate G over AB basically. G dash can be defined. So I think you should take it in that spirit. So if I say that, then though it has to be one can be very, very critical, and because then a lot of things is missing in that question, that the range of F should be contained in AB, and hence then you can define G dash on that. So that becomes too harsh kind of thing. You need not. This is okay. I understand from a very logical point of view, you are correct, but actually from a working point of view, so this course is about giving you a working feel of calculus. From a working point of view, this is okay. So you're assuming that G dash is exists, and G dash, the function F, its range comes within AB, and I can define it, and that. That's the whole point.
Okay, sir. Thank you. Thank you, sir.
Anything else? Anybody? Ajay, somebody.
Hello, sir. Good evening, sir.
Good evening.
First of all, it's my pleasure that I am listening you live, because till today I followed on you only on YouTube. So my question is very basic, sir. What is a necessary condition in theorem, sir? What is the meaning of a necessary condition? I got it. Sufficient condition means in your intermediate values theorem lecture, sir, but not
necessary condition is this. Let me tell you. Necessary condition is always a negative statement. Okay. For example, if I say that F is a function from R to R and it is differentiable, then if X is a local minimizer of F over R, then F dash X equal to 0. So what does it mean? It means that if X is a local minimizer, it implies that the derivative at that point is 0. Right? But if the derivative at that some point is 0, it doesn't tell. The opposite way, it doesn't hold. Okay. So what does it say? It says that, so the statement P is a statement. So in logic, there's a link like this. If a statement P implies a statement Q, then the negation of Q implies the negation of P. So P is the statement, X is the local minimizer. And that implies f dash x equal to 0. That is the statement Q. So what is negation of Q? Negation of Q is the statement that f dash x is not equal to 0. Then implies negation of P, which means that X is not a local minimizer. So the statement, a necessary condition tells you that if that is violated, then the condition which implied this condition doesn't hold true. So if f dash x is not equal to 0, x cannot be a local minimizer. So it is a check of that. So it is a guarantee that, okay, this point may be a local minimizer. If it was not equal to 0, then of course there was no way. If f dash x is not equal to 0, then no way x is a local minimizer. So necessary condition actually gives a negative certificate, that it tells you that it guarantees you when a point is not a local minimizer. It never tells you when a point is a local minimizer. That will be guaranteed by the sufficient condition that you learn, that f double dash x is strictly greater than 0 or strictly less than 0 for maximum or minimum. It depends on whatever. So suppose you want to talk about minima, then you check whether f double dash is strictly bigger than 0. So that guarantees you that it will be a minimizer. Once f dash x equal to 0, added with that, if you find that f double dash x is also strictly greater than 0, then that point is a minimizer. So sufficient condition guarantees you a positive statement, a positive happening, while a negative statement is guaranteed by a necessary condition. That is the key fact. F dash x equal to 0 does not tell you that x is a minimizer. If there is a point x for which the derivative vanishes, nowhere it is telling you that it is a minimizer or a maximizer. Only it tells you that if this condition doesn't hold, then the point x cannot be a minimizer or maximizer. So that's the idea. Okay, Ajay?
Yes, sir. Thank you, sir.
मतलब
So
हिंदी में
in
अगर
necessary conditions,
f dash x 0 है, उसके मतलब ये नहीं कि x कोई मिनिमाइजर और मैक्सिमाइजर है. उसके मतलब कुछ नहीं है. f dash x अगर 0 नहीं है, तो उसके मतलब है कि x मिनिमाइजर और मैक्सिमाइजर नहीं है. वो नहीं स्टेटमेंट को इम्प्लाई करता है. Okay. So that is why necessary conditions are very important, because that will give you a testing. So if you have a point and you claim that it is a minimizer, I'll plug it into the necessary condition. If the necessary condition fails, then what you are telling, आप जो बोल रहे हो सही नहीं.
Okay, sir. So that means a necessary condition in the sense of negation.
Necessary condition is essentially talking about negation. It tells you when a point is not something. So when a point is something, something must happen. So if that doesn't happen, the point is not that. So when you check, when you want to, but they are also calculation instruments, because if you want to see whether compute a point to be a minimizer, you have to first check whether f dash x must be equal to 0. If it doesn't, then it will definitely be not a minimizer. Because of the negative fact, you have to always check whether f dash x equal to 0 if you claim a point is a minimizer, and then check through the sufficiency condition, which will guarantee that it is. Tell me.
Yes, sir. Got it, sir.
Thank you.
Thank you, sir.
Others, if you have any doubts, please ask. Preetham, Nazira Begum.
No, every function defined over a closed interval xy in the Riemann is Riemann integrable if the function is bounded. There's a proof for that. you need to see the books for the proof, Pritam. I don't have anything here to sit down and do the proof. I need to have that. That's not here, the writing pad. So this is just, so these kind of things you need to give a proof. So if you want to prove a statement as wrong, as you want this one, you need to provide a counter example. So when you want to prove something, when you want to prove something happens for every instance, then you need a proof. When you want to claim that something happens for every instance, you have to give a proof. And when you want to claim that something is wrong, as you want this statement that every function defined over a closed interval xy is Riemann integral if the function is bounded. It's not true. Take the function fx equal to 1 if x is q, and x equal to 0, and equal to 0 if x is equal to 1 if x is rational, equal to 0 if x is not rational, and choose x between 0 and 1. So it is defined over the interval 0 and 1, and this is how the function is defined. It is bounded, right? Bounded above and below. But it is not Riemann integral. This is the famous Dirichlet function. So just to prove that this statement is wrong, I just have to provide one counter example. So this is a counter example. So fx equal to 1 if x is rational, fx equal to 0 for x is irrational. This function is defined over the interval 0, 1. So this function actually has uncountable discontinuities. If we have countable discontinuities, it will be Riemann integral. Because it has uncountable discontinuities, the problem is coming. So any question, Pritam? So when you want to prove a statement to be wrong, provide a counter example. If you want to prove a statement to be correct, you have to, when a statement is holding for every instance, you have to give a proof.
Okay, sir. Sir, but Dirichlet function is integrable with kh integral.
I is integral with kh integral and also with Lebesgue integral. So that's the whole point, actually. Riemann integral doesn't tell you. Dirichlet was Riemann's teacher, you know. After finishing his doctorate, he spent a lot of time with Dirichlet. Riemann was a student of Carl Friedrich Gauss. So,
Sir, what is the basic difference from the Riemann integral to the kh integral?
kh integral, the way they partition, that is something called delta fine partitions, and that where you can control the delta. Here you fix the delta and you take that x plus h, that h is not, it is fixed, x plus h, x plus 2h, and then you create the sum and then keep on reducing the value of h. That's the, and then see what the limit goes. That's Riemann integral. But there is a, you can control the delta. The delta is controlled for every partition. You can control the delta. So the delta for every partitioning is very different. So that's the thing. So that's how you control kh. If you look at the lectures, you will see we have proved the fact that 0, 1, this particular function is kh integrable. It's very unfortunate that kh integral is not taught at even at the college level. So if you go through a lecture on kh integrals, have you gone through the lecture on kh integrals?
Yes, sir, I have watched the lectures, but the week is Riemann integral week is I'm finding it difficult. It's little.
You have to watch it several times. There's some that is the whole concept of delta fine partition. Partitioning depending on a parameter. Partition delta is a function. It is not just a fixed number. The partition
Yes, sir.
length is not a fixed number. Partition length is changing. And that is why this integrability is done. And the answer is 0.
Yes, sir.
So that is slightly, it's a difficult thing. I don't agree that it's very simple. But you can actually, if you look at the lecture once again, you will be able to understand.
Yes, sir.
Anyone else? Murli, have a look if there is anyone else.
Yes, sir. Participants, if you have any queries, please ask it without any delay. Otherwise, we may end the session soon.
Sir, one more thing.
Yeah, Pritam,
So
tell me.
we have done the Newton's method for solving equations.
Hmm.
In machine learning, today we use the gradient descent method.
Hmm.
Is this the same thing or it's
No,
come
no,
from
no.
the Newton's method?
You get the gradient descent method doesn't come from Newton method. It is a very different thing.
It's looking similar.
No, it might look because it's a iterative algorithm. So gradient descent method doesn't come. I am an optimizer. So gradient descent method doesn't come in that from Newton's method. Gradient descent method is one class of descent methods in optimization. Newton method is another class of descent methods. So they are two different methods. Newton method is faster actually. And for quadratic, strongly convex quadratic functions, they are extremely fast. But it doesn't matter what it is. The classical gradient descent method is very slow, and that is why when you give a stochastic version to it, that is when you get all this kind of lot of functions are there, when you add up those functions and you take some of them randomly and then construct a mini batch and just only take some gradient and the sum of the gradients of those functions, then it speeds up. That is called the stochastic gradient descent. And only comes quite near the minimizer. But from there it again becomes very slow. So for about computer science people, that's very near minimizer would do, or local minimizer would do. If you have convex functions, then you have global minimality. I don't know whether you know about convex functions. If you, I think convex functions was also
Yes, the convention has been mentioned in the class.
so convex functions. The beauty is that every critical point is a global minimizer. So
Yes, sir.
or you even if or anything. So essentially, you are trying to find a when you have convex functions, you are trying to find a critical point. But all these descent methods mean that every step you are decreasing the value of the function. So even if you go near the approximate point solution and near the point, near a critical point, you are actually an approximation of the solution. That's okay.
Okay, sir.
Oh, you are talking about fractal basins. You know what are fractals? Pandeji. Pandeji, you know what are fractals?
Mr. Pandey, can you unmute and ask your query?
Pandey Saab.
हेलो सर।
बोलिए।
हेलो
बोलिए।
सर ये मैं इसको पढ़ा था, समझ में नहीं आया था मुझे जरा भी ये चीज।
आप कौन सी लेवल पे है वो मुझे जानना चाहिए।
सर ये बेसिक सेकंड ईयर।
हाँ तो फ्रैक्टल्स के लिए किताब है एमएफ बर्न्सले की सो वो किताब थोड़ा अगर आप देखें तो उस पे वहाँ पे ये प्रॉब्लम डिस्कस्ड है बिकॉज फ्रैक्टल समझने के लिए आपको क्रिटिक स्पेस वगैरह को जानना चाहिए हाउस स्पेस वगैरह वो सब आ जाएगा फ्रैक्टल्स आर सेल्फ रिपीटिंग पैटर्न्स that's a very basic way of saying it, but when you want to learn it mathematically, so they have just wrote that these are all basins of attractions and name of the book okay I'm writing ये डोवर पब्लिकेशन में मिलता है So
सर
fractals
बुक का नाम क्या था?
पे जो patterns created होता है, those are of the form of fractals. They are self patterns, and they are called basins of attraction. So you have those regions. You can figure out regions from where if you start the starting point, you will have a fast convergence of the solution. So those are called basins of attraction. So any point in that region will be very fast attracted towards you start from a point as an initial starting point, you'll be very fast, very good speed, you'll move towards the actual solution. So अगर आप वो रीजन से कोई भी एक पॉइंट को स्टार्टिंग पॉइंट बना लेंगे न्यूटन मेथड का, उसको आप चालू करेंगे मेथड का, तो वो मेथड आपको बहुत जल्द ऑप्टिमा के इक्वेशन का सॉल्यूशन के पास ले जाएगा। तो इसीलिए उसको बेसिस ऑफ अट्रैक्शन बोलते हैं। अब बोलिए पांडे जी।
ओके सर, थैंक यू।
Participants, any other queries? So if there are no queries, then
yeah, Murli,
in the session. Yes, sir.
Is it possible that for this particular course, calculus of one real variable, because there's so much demand for this course, can this course, some people during the vacation time, etc., can they come in person and have a fresh session before, or I don't know, maybe that can be done as a part of an NPTEL outreach.
Right.
MOOCs outreach.
Yes, sir. So we have an internship program also, sir. Like whoever is stopping the exams, we will request them to come here and spend like 2 weeks time, 2 to 4 weeks time, depending upon faculty's availability.
They can come and talk to me. If I would like to see some good students come and talk about calculus.
Sure, sir. Definitely, sir. Definitely, sir. We will make an announcement in the portal itself. Once the examination is over, who is stopping the examination, we will identify those students and then request them. And we also check with you your availability, and then we will plan accordingly, sir.
Yeah, that would be good actually.
Thank you, sir. Thank you.
To teach such good students.
Sure, sir. Definitely, sir. We can have that, sir.
Okay.
Participants, can we end the session now if there are no queries? Because there is another session at 5 o'clock. So shall we close, sir?
Yeah.
Okay, sir. Thank you so much, sir, for your valuable time. Thank you, participants, for joining in. See you, sir. Thank you, sir.
Okay, thank you.
Bye, sir.
Thank you, sir.
Thank you, sir.
Yeah, thank you. Thank you, participants. I'm closing the session.